Hey guys, here's a second drop problem as part of this vertical motion we've been working with, and just going to solve something a little differently here. So here's our problem. We're going to drop an object. Again, it doesn't matter which object it is. It could be a ball, it could be a piano, we could drop our cat. Well, that might offend some people, so we won't drop our cat. We could drop anything. If we're ignoring air resistance, which is what we do in free fall motion problems, vertical motion, we ignore air resistance just to simplify things. It doesn't matter the object. We're going to say it lands with a velocity of 20 meters per second. That means when it hits the ground, the object is going to fall to the ground, and when it hits and impacts the ground there, it's going at 20 meters per second. We want to find out, hey, how long did it fall? To get to that, if we dropped it, and what's the height we dropped from. So here's the key to all drop problems. Our initial velocity is equal to 0 meters per second. That means when we drop it, it's just going to be 0. Sorry about that, get some kids here. So that's the key. Again, we're going to have gravity is here. Try that again. Gravity is straight down at 9.8 meters per second squared. And we call that G, we call that the positive direction. So we go back, we have our three equations. Let me put those in here quickly. Alright, there's our equations that we're going to use to solve. Whoa! Try that again. I don't know what's up with that. A little better there. I'm still learning at this, as you can tell. Whoa! Alright, I'm just going to stop playing and put a box around there. Okay. Alright. Sorry about that, guys. Alright, so we need to solve the problem. What do we know here? I'm going to underline in red here all the things we know. We know initial velocity, which is 0. We know that it impacts with a final velocity of 20 meters per second. We know half, we know 2, we know gravity. Okay, what we don't know is time. That's our t. We know gravity up here too. And we don't know the height, which is delta y. Alright, so for those we're looking for t, and for this one we're looking for delta y. Now again, looking at the equations, we can only use the ones that have one unknown, meaning one variable that is not, we don't know the number for, the numeric value of. And basically looking at this, it's either starting with this first one or the second one. We could use the first, or we can use the second. We cannot use the third because we don't know t and we don't know delta y. So let's start at the top. We'll just do v equals VO plus GT. Again, positive direction down. It is impacting with 20. We drop it. That's the key to a drop problem or a free fall problem, is initial velocity 0 plus a 9.8 for gravity. Again, that's positive, so it's going down, equals t. So t is going to equal 20 over 9.8, which is pretty much right around 2 seconds. All right, I don't have a calculator in front of me, but it's going to be 2 and just a little bit seconds. That's after 2 Mississippi, it's going to hit the ground, meaning it takes a little over 2 seconds for the object, when we drop it, to reach 20 meters per second, which is upwards of 40 miles an hour. Okay, now we can go to the distance. Now we know delta y, vt, half gt squared. Again, we still pick positive as downwards. Our initial velocity is 0 times 2 seconds plus half, again positive 9.8 because everything is falling downwards, times 2 seconds squared, or ballpark, that becomes 0 plus that's 4.9 times a little over 4. That's almost 20 meters if you ballpark that. 4.9 is roughly 5 times 2 squared is 4. 5 times 4, about 20 meters. So there solves a different type of drop problem with a little bit of sketchy messiness up there. I hope you're able to read what I'm writing here and that these are becoming helpful to you. If they are, and you are in one of my classes, please email me to let me know that these are being helpful, and I'll continue to do these. So there's a second drop problem. From here we're going to work on, move towards throwing things. So enjoy, and we'll talk to you then.